Have you ever wondered how that shiny thin sheet of aluminum foil that you use in your kitchen or for your DIY projects is made? It's a material so familiar, so integral to our everyday lives, yet its creation remains a mystery to many. From preserving your leftovers to shielding your electronics, aluminum foil's applications are as versatile as they are numerous. So, how does this wonder material come to be? Well, brace yourselves as today, we unravel the fascinating journey of aluminum from raw bauxite to the foil in your kitchen. Aluminum doesn't exist in a pure form naturally, but as bauxite. The journey of aluminum foil starts from here. You see, bauxite is a rock rich in aluminum ore. It's named after Les Baux, a village in southern France where it was first discovered back in the early 19th century. This reddish-brown sedimentary rock is found in large quantities in select locations around the world, including Australia, Guinea, Brazil, and Jamaica. Bauxite mining is a fascinating process. It begins with a survey to locate and estimate the amount of bauxite present in an area. Once a profitable deposit is discovered, the mining process kicks into gear. The topsoil is first removed and stored for later use in the mine's reclamation process. The bauxite layer beneath is then extracted using heavy machinery like excavators and loaders. But it's not as simple as just digging it up and shipping it off. Bauxite is usually found near the surface, so open pit or surface mining is the most common method. However, in some cases, underground mining may be required. Now let's talk about the environmental implications. Like any mining operation, bauxite mining has its environmental challenges. The removal of the topsoil can lead to erosion and loss of biodiversity. The mining process also produces dust and noise pollution. However, most bauxite mining companies are committed to sustainable practices. They aim to minimize their environmental footprint through land rehabilitation, dust control measures, and responsible waste management. It's also worth noting that bauxite is a renewable resource, as it forms from weathering of aluminum-rich rocks over millions of years. So while the mining process might seem invasive, it's part of a natural cycle that's been going on for a very, very long time. Once the bauxite is mined, it's not aluminum just yet. The ore has to undergo a series of processes to extract the aluminum, but that's a story for another scene. The extracted bauxite can't be used directly, it needs to be processed into alumina first. This is where the magic of the Bayer process comes in. Named after the Austrian chemist Carl Joseph Bayer, this process is the principal industrial way of refining bauxite to produce alumina or aluminum oxide. So, how does this transformation take place? Well, it might sound complicated, but it's actually a fascinating journey. Let's dive in. The Bayer process begins with the bauxite being washed in a hot solution of sodium hydroxide. This sodium hydroxide solution, often referred to as lye, is used because it's excellent at breaking down the bauxite. It dissolves the aluminum compounds in the bauxite, leaving behind any impurities, which are often made up of silica, iron oxides, and titanium dioxide. Now, this process doesn't happen in an instant. It's a meticulous procedure that happens under high pressure and temperature, often taking several hours to complete. The solution is kept at a temperature of about 250 degrees Celsius, and under pressures ranging up to several atmospheres. After this, the solution is cooled, and the aluminum hydroxide precipitates out. This is then heated in a kiln, a type of oven that can reach extreme temperatures, to give us alumina. The alumina, which looks like a fine white powder, is the result of all this hard work. It's a crucial step forward in our journey towards creating aluminum. And it's worth noting that this process is incredibly efficient, with around 99% of the bauxite being converted into alumina. It's all a bit of a science experiment, isn't it? But without this innovative process, we wouldn't be able to create the aluminum that we use in our everyday lives. From here, it's on to the next stage: electrolysis. Now that we have alumina, it's time to turn it into the aluminum we're familiar with. Now, the alumina undergoes a process called electrolysis to yield aluminum. So what's this electrolysis? Let's dive right in. Electrolysis, in simplest terms, is a method of using an electric current to drive a non-spontaneous chemical reaction. Think of it as a sort of alchemical magic trick, where we use electricity to transform one substance into another. In the case of aluminum, we're using electrolysis to break down alumina, a compound of aluminum and oxygen, into pure aluminum and carbon dioxide. This happens in a large, high-temperature steel vat known as an electrolytic cell. The alumina is dissolved in a molten substance called cryolite, which lowers the melting point and increases the conductivity of the mix. Now here's where the magic happens. A powerful electric current is passed through the mixture. This current is so strong it literally rips the oxygen atoms right off the alumina. This leaves us with pure liquid aluminum, which is denser than the cryolite and sinks to the bottom of the vat. But what about the oxygen? Well, it doesn't just disappear. The oxygen atoms combine with carbon electrodes used to pass the electric current, forming carbon dioxide. This gas is then captured and treated before being released into the atmosphere. And there you have it. Through the power of electrolysis, we've transformed a compound of aluminum and oxygen into pure, shiny, liquid aluminum. It's a process that's as fascinating as it is vital. Because without it, we wouldn't have the aluminum we use in so many aspects of our daily lives. Now you might wonder why we go through all this trouble when aluminum is the most abundant metal in the Earth's crust. The reason is that aluminum doesn't occur naturally in a pure form. It's always found combined with other elements, and electrolysis is the most efficient way to separate it. And voila, we have pure aluminum, but we are not at the foil stage yet. So, stick around to see how we get from this molten metal to the thin, shiny foil that's probably in your kitchen right now. Now that we have our aluminum, it's time to get rolling. In the world of aluminum production, rolling is a crucial process. It transforms the aluminum from bulky blocks into the thin sheets we're familiar with. But how does it happen? Well, it's all about heat and pressure, and it happens in 3 stages: hot rolling, cold rolling, and the final roll. First up is hot rolling. The aluminum blocks, also known as ingots, are heated to a specific temperature. This temperature is critical, folks. It needs to be high enough to make the aluminum malleable, but not so high that it melts. We're talking about over 900 degrees Fahrenheit. Once the ingots are heated, they are passed between large rollers under great pressure. This process flattens the ingots into sheets that are still quite thick, but much thinner than they were. Next, we move on to cold rolling. As the name suggests, this process takes place at room temperature. The hot-rolled aluminum sheets are fed through smaller rollers. These rollers apply even more pressure than the hot rolling process, further thinning the sheets. It's during this stage that the aluminum reaches the desired thickness. Now you might think we're done, but there's still one more step: the final roll. This is the finishing touch, the icing on the cake. In the final roll, the aluminum goes through another set of rollers, this time with a polished surface. This gives the aluminum that shiny, smooth finish we all recognize. At this point, we have a continuous sheet of aluminum that's as thin as a human hair and as shiny as a new penny. But guess what? It's still not aluminum foil. Even after all that rolling, there's still one more stage to go through. Now, we're at the last stage before we can call it aluminum foil. The final step in the process is known as annealing. This is a crucial phase where the aluminum foil is subjected to high temperatures. You might be wondering, why is this necessary? Well, annealing is all about strengthening and stabilizing the metal. It's like a yoga session for the foil, allowing it to stretch and flex without breaking. The foil, which has been rolled thin, is now treated with heat. It's sent into an annealing oven where temperatures can reach up to 600 degrees Fahrenheit. It's a bit like baking, but instead of a loaf of bread, we're crafting the perfect sheet of aluminum foil. Now imagine the foil relaxing, its inner structure changing as the heat does its magic. The high temperature causes the atoms in the foil to vibrate and move, eliminating any stresses caused by the rolling process. This results in a foil that's more flexible and less prone to tearing, which is exactly what we need. But that's not the end. After the heat treatment, the foil is cooled down gradually. This cooling process is just as important as the heating. It allows the foil to settle and lock in its new strengthened structure. And there you have it, the shiny, versatile aluminum foil ready for use. This common household item has undergone a fascinating journey, from bauxite mining to this final touch of annealing. It's a testament to how much care and precision goes into creating something we often take for granted. So, that's the incredible journey of aluminum foil. From the humble beginnings of bauxite mining to the transformation into alumina, followed by the electrifying process of electrolysis. Then, it's rolled to the perfect thickness and annealed for that final touch. It's quite a process, isn't it? A marvel of modern engineering that sits right in your kitchen. Next time you reach for that roll of aluminum foil, remember the remarkable process it's been through. Thanks for joining us on this journey. Don't forget to subscribe for more fascinating insights.